Hi, welcome to Unit 2, Quiz Practice Select Solutions, questions 6 and 7. All right, for questions 6 and 7, they're telling you a student weighs out a certain amount of each barium salt listed above, I should say below, and mixes each salt in enough water to make a 100 milliliter solution. Which solution would have the highest concentration of barium ions? Okay, so I want to know about which one would have the highest concentration of barium ions. And I'm being told that I'm mixing each salt in enough water. So the reason why I underline that is because you're kind of needing to visualize what's happening. And if you close your eyes and visualize what's happening, you should envision someone mixing a salt in water. So what process is this? This is dissolution, which means we're dissolving something. So what happens when you dissolve a salt in water? Remember, salts ionize, and that means they're going to break apart into ions. And this is where the barium 2 plus ion comes from. So all of these salts have barium in them, and then when you dissolve them in water, they're going to ionize into the barium cation and then the anion. So the question that we have is which one would give the most ions? And for that, we need to do a couple of things. One, the first thing we probably want to do is we want to write a balanced chemical equation, but we're also going to need to, in writing it, think about solubility rules to know which one of these ionizes completely, meaning breaks apart completely, and which one we would use the double arrows for to indicate that it doesn't break apart or ionize completely. Okay, so we're going to write our dissolution equations, and in writing the equations, remember, you're going to use solubility rules to help you pick the arrows, whether it's a single arrow because all of it ionizes, so we use those for soluble salts, or whether it's a double arrow because it only partially ionizes, and we use that for slightly soluble or insoluble salts. Take a moment now to pause the video, and I want you to write the dissolution equations for these 4 salts, and your arrows should be also correct, so you want to consider solubility rules. When you press play again, the dissolution equations will be shown. All right, so for barium hydroxide, it breaks apart into the barium ion in 2 hydroxides. Barium phosphate breaks apart into 3 barium ions in 1 phosphate. Barium sulfate breaks apart into 1 barium ion and 1 sulfate. And then barium chloride breaks apart into 1 barium ion and 2 chloride. And for the middle two, barium phosphate and barium sulfate, according to the solubility rules, these are insoluble. And so as a result, I put this double arrows. Okay, so now the question is which one's going to give me the most? Barium. Well, barium ions. Well, at first you may think, oh, it's got to be barium phosphate because there are 3 of them. So for 1 barium phosphate, it breaks apart into 3. But remember, barium phosphate is an insoluble salt. So you see that double arrow there? That means that, well, what does that mean actually? Yeah, it means that not all of it breaks apart into ions. So even though we have a coefficient here of 3, and if we had, like, let's say there was 1 mole of barium phosphate in the solution, doesn't mean we'll have 3 moles of barium because it's not completely ionized. So the amount we have will depend on our KSP value, which we don't have, but we do know, though, because this is not soluble, very little of it is going to form barium, break up ionize into barium and phosphate. So therefore, barium phosphate, even though it has a coefficient of 3, would not work because it is not soluble. So what I'm going to do here is, with that being said, I'm going to now calculate and figure out what my concentration of barium ions are. And for that, what I'll do is I'll solve for the moles of barium salt. And I did that simply by doing mass over molar mass. Now, on an AP exam, this would be a multiple choice or a part 1 section question. And those questions you're not allowed to use a calculator. But you can tell, as you can see, that the numbers here are made so that you don't need a calculator. You could do this sort of thing mentally. So I have my moles, and I just write down what I get from my moles by dividing the mass over the molar mass. And then to get the moles of barium, what I look at is I look at the dissolution equations. So for the first one, the moles of barium, it's a 1-to-1 barium hydroxide to barium. So the moles of barium salt will be the moles of barium ion. And then for the last one, it's the same thing. It's a 1-to-1 molar ratio. So the moles of barium salt is the moles of barium ion. And then to get the concentration, I would divide it by 100 milliliters, which I converted to liters. So 100 milliliters into liters is 0.1 liters. So I divide these moles by 0.1 liters, and that's how I get the molarity. You don't even need to calculate the molarity here. You can just compare the moles since the volumes are the same for all solutions. So you can see here that barium hydroxide has the most moles of barium, or the greatest concentration, excuse me, of barium. For the ones in the middle, we can't really do anything with them because we don't have the KSP, so and it's insoluble, so we know that these wouldn't have the highest concentrations. The answer here is barium hydroxide. Okay, for question 7, they're kind of flipping it, and in this case, they're asking for the one with the lowest concentration of barium ion. And so, well, we know that the lowest concentrations are going to come from the insoluble salts. However, we don't have the KSP, so we cannot calculate. The concentration of barium ions in these insoluble salts. We need the KSP to do it. So in this case, there's not enough information. So for question 7, not enough. Can't do it. If you had the KSP, you could do it. So anyway, I hope you found this video helpful, and have a quality day.